Hello everyone, I welcome you all to Academy, where you can aim for higher goals, aware of those goals, and achieve them through Academy. Academy is for you to take the right decision, to move in the right direction, and to reach at the right destination. So in this lesson, we are going to measure the energy absorption of the lattice structure, which is underwent the quasi-static compression. Okay, so for that we have the some mathematical relation. So based on that, we are going to use these formulas to measure the energy absorption, and plateau stress and energy absorption, energy efficiency. Got it? So in this lecture, generally you can measure the energy absorption using different methods. So in this particular lesson, we are only focusing on the energy efficiency method, so which is most accurate method as compared to other. So let's focus on this particular one. So in other lectures, I will explain you how to measure the energy absorption using other methods. So let's try to focus only on the energy efficiency method. So here, uh, you can see the energy absorption. It means the area under the curve of the stress strain. Okay. So here we have the stress and strain. So you can say that like this. Where is this? Where is this? Okay. So you can plot like we have the stress and strain. Okay, this is our particular stress and this is our particular strain. Now our structure has a response of stress strain, so like this. Okay, so this is our particular elastic region up to like up to this our elastic region, and up to this, or you can say that, but it is not accurately, just I'm explaining you. This is our elastic region and this is our plateau region. Okay, and this is our densification region where the stress is suddenly raised with the lower strain values. Okay, so this is the area where most of the lattice structures have the different behavior. So it is up to you how you are designing your lattice structure, and accordingly this particular plateau region will changes as per the applying the external loading. So it defines the material capabilities of the energy absorption. So this particular region must be higher so that that particular structure can absorb the more amount of energy. So you need to think in such a way that you need to design of that particular unit cell architecture. Okay, so these are the three particular regions we have. So now this particular area under the curve up to this point, like you can measure that particular efficiency method. So up to this particular point, this is known as a densification strain. So we need to evaluate this is known as densification strain, and the area under the curve up to this is known as energy absorption. Yeah, here, as I said, as I said, just wait. Yeah, area under this curve up to densification point, densification strain, is known as our energy absorption. Okay, energy absorption. Okay, and the plateau stress is from the yield stress, from yield stress to this particular stress, the stress respective to this particular densification strain. So the average of this particular value is known as our particular plateau stress, and with respect to this particular densification strain, we can get the maximum efficiency value. I can show you in the next plot. Like it will looks like this. I can draw like I will show you. For example, it looks like, oh sorry, oh, you can say that like it will go like this, like this, like this, like this, like this, and suddenly fell down. This is our efficiency curve. You can say that efficiency curve. So this particular, actually it looks like this. Just for explanation purpose, I'm explaining like this. So this particular point known as the efficiency, maximum efficiency value. So we will draw this, and accordingly we can measure, take that particular value. Okay, so this is how we are going to. This is the concept behind this. Now these are the relations we need to consider for measuring these particular energy absorption. Okay, energy absorption, sorry, energy absorption and efficiency and plateau stress. Okay, as I said, this is from zero strains to densification strain, and the stress into respective strain value. So area, this you need to consider as area. And if you see the plateau stress, this is from zero to densification strain, and it is the average of the stress. Okay, so this relation you need to consider, and later on you can also consider the efficiency values. So this is the relation like maximum, like energy divided by the maximum stress value. So these relations you can use in Excel sheet like this, where to measure the to measure the we need to consider the trapezoidal rule to measure the area under the curve. So for that, we need to use this particular formula by considering the stress strain. Okay, so and then we need to measure the cumulative area. So these are the independent particular, like it is saying that we have the stress, sorry, we have the stress strain, and yeah. So here, this particular area, trapezoidal area, we are measuring, but there we are dividing this particular stress response into different multiple trapezoidal areas, so we need to cumulate them. So that's why we need to use this particular, we need to sum of them, sum. So total sum of the area is considered the energy absorption. So till this we are measuring the energy absorption, and then we are going to measure the plateau stress, and then we are also going to measure this particular efficiency value. Got it? Yeah. So let's go ahead, come back to our previous results. Here we have this sheet is with respect to elastic modulus, so you can give the name it as elastic modulus, and this sheet is for measuring the yield stress, so we can give this name as yield stress. Okay, you can highlight this also if you want. So now we can create the new excel sheet, so by giving the name as energy absorption. So within this we can measure so many things. So for that, here we can copy this but initial our stress strain response, the one which we measured here, the final one. Okay, so this copy, just simply copy this data. So our initial energy absorption, just paste it here by considering that as a values. Yeah. So now we need to measure the area, the particular area. So for that, we can measure the area, square you can say. So the relation is like just wait. Yeah, here what exactly we did, I will show you. Here we did the stress values plus its previous stress value into half of it, average we are making it. So just half means 0.5 into the strain and its previous strain values. Got it? So this is our area under the curve. Just double click it. Got it? So this is how we need to measure our particular area. Now we need to measure the sum of the area. You can use this relation as it is. Sum of the area, we can use the function as a sum function, and from here to just press this. Now we are going to measure the sum of the area. So for that, just press and use the sum function and consider this area as our initial value. So we are adding this particular strain area plus the next area value. Just press this shift and colon. Just wait. Just press and make it as a constant value. From there to select this, make it so now we need to measure the sum of the area of particular cumulative area we need to use. So for that, we can use some area and use this relation as it is. So let's use the formula, and there we can use the sum function. So from here we can make it as a constant, and from here to the, sorry, from here to here we are going to evaluate our sum values and make it this initial value as a constant. Press simply F4. Okay, then just press the enter. Got it? So what we did, just we selected the initial value and this two area we summed. So like that, this formula we are going to use. Okay, now just simply double click it here. So like this, we have measured the respective sum area. Now we need to measure the efficiency. So for that, we need to use the formula. So this relation we need to use to measure the efficiency value. So by measuring this particular efficiency value, we can able to measure the particular densification strain. So from that, we can measure plateau stress, we can measure energy absorption. So let's use this particular formula with respect to our given data. So here we have the D3 means the average, this some cumulative sum energy, and then maximum of stress values from given values. Okay, so let's go ahead, come back here. So we are going to measure the efficiency. It doesn't have any units. So as per the formula, we need to use sum of the area divided by maximum of, we can use the maximum function, stress, press F4, stress 2, stress, and sorry, just wait, press F4 here, and here you can press B4 because this next value. So within these two, it will consider the maximum value. Like you can drag it. Even you can see this. So it is considering the maximum value of these particular values. I hope you got it. So you just need to consider the sum of the area D3 and use the maximum function and consider this initial stress value and then consecutive values. So like that we have measured the efficiency. Now we can plot the efficiency curve. So for that, stress versus like uh, efficiency versus strain. So let's copy the strain value and paste it here, and copy the efficiency value, paste it here, and we can separate these two as well. There is no problem. Now we can plot this. Yeah, here you can see we have got the respective efficiency curve. So here there is some deviation. So this deviation came because of our some negative values, I hope. So yeah, so these negative values we can remove. Now you can see, so here this axis is our respective efficiency and this is strain. As our strain is increasing, the efficiency value goes on increasing. There is some plateau due to some our structure behavior, and it still further went up to some 0.6 plus strain, densification strain. So our particular densification strain is here, so we can measure it. So this is our particular efficiency value, maximum efficiency value. So from here we can measure. Now we can focus on the measuring the maximum. Just keep it as it is. So let's, you can use here maximum efficiency. So for that we can use the relation as maximum function and select this efficiency and just press Control Shift down arrow. So here what we are trying is finding the maximum value of the efficiency. So our maximum value is this particular value. So now you can simply copy this value and paste it as a number. Okay, and now you can just simply copy this value and find here. Just press this and Control F, find here. So this value is belongs to this particular 163. Highlight this. So here, now, as we know that this is our area, sum of the area and efficiency and respective strain. Okay, so simply copy this entire row up to this. Okay, and go up, simply paste it here as a number values and get these names as it is. Okay, so here the sum of the area means our energy absorption and efficiency is our maximum efficiency, and respective strain is this. So now we have most of the data densification strain, densification strain as strain. Just simply cut it here and paste it here. So densification strain value is like here, this is value. Just simply copy here. And next is so energy absorption. Energy absorption. The sum of the area is our energy absorption. Just paste it here. And maximum efficiency, as we know this, densification strain and energy absorption. So finally, we have measured the maximum efficiency and densification strain and energy absorption. So this is our energy absorption, and you can consider the units as stress units and Newton per mm square. So like that, we have the, I can show you, just wait. Like we have Newton per mm square na. Similarly, by mm strain is mm per mm. So here you can say Newton mm, this mm goes up, and we have mm cube, isn't it? These two. So this can be considered as Newton 10 to the power of minus 3 meters into uh, like uh, like 10 to the power of minus 3 meter cube. So this Newton meter is joule, and 10 to the power of minus 3, 10 to the power of minus 9 into meter cube, isn't it? So now this 10 to the power of minus 9 goes up, then become plus. So it has 10 to the power of 6. So this is mega joule divided by meter cube. So this is our units. So you can use this unit there. Now come back to our discussion. So now what value is left? That is the plateau stress. So what is plateau stress? It is the average. There are some various standards. Either you can take the average from 20 percentage to the 40 percentage of strain, of respect 20 from strain values from 20 percentage to 20 percentage to 40 percentage. So there are some standard like ASTM, ASTM and ISO standards. You can follow them, but generally what I used to do, like there are some other method, like we can take the average from yield stress to densification, the stress with respect to the densification sign. So here the plateau stress we are going to measure from the stress with respect to yield strain and the stress with respect to densification strain. So let's take that particular value. So for before that we must know the yield stress value. So our yield stress value is 2.55. So let's highlight that here. Where is the 2.55 stress value? 2.55 is, you can consider this as 2.55. Okay, so its value is 8080. It's 88 row. Okay, now we are going to measure the plateau stress in MPa, megapascal, you can say. So it is the average. We can use the average function. Average. So here it is a B column. B 88, row 2. B I think 1600 row. We don't know. I will exactly tell you. We will change these values. First now you can press it. Just go down. But 88 now. 88. So how much we use? Yeah, 88. So this is stress now, B. So B 88. Now we must know this value. Just wait. Efficiency now. Yeah. What is the root value? Root value is a 1613. Okay. So finally we also measured the plateau stress. Okay, got it? So this is our plateau stress value. So this is how you can be able to measure the plateau stress using the average of the stress with respect to yield strain and the stress with respect to densification strain. So we must know the stress with respect to the yield strain, and we must know the stress with respect to the densification strain. So for that we have measured the densification strain using energy maximum efficiency method. So here from this particular graph we can clearly identify the maximum value of efficiency and densification strain here, respective densification strain. And this strain is considered as our densification strain, where densification used to start, the densification region where the stress is used to rise suddenly, and the efficiency goes down. So and considering that densification strain and the starting strain elastic, and from this initial to densification strain we mm, like uh, we measure the energy absorption using the sum of the area relation. So I hope you understood till now. So if you have any doubt, please let me know. So with this I am concluding. So with this I'm concluding. Thank you.